Hi everyone, hope you all are good. We are here for grade 6 math. So we're working on the book that is Math Makes Sense grade 6. So we're working on chapter 1 that is patterns and equations. The lesson we're going to cover from the chapter is keeping equations balanced. Then we'll start the new chapter that is understanding numbers, and the lesson we're going to cover is exploring large numbers. So let's just start with the first lesson. So here I'm on the book Chapter 1 that is patterns and equations. The lesson is keeping equations balanced. So let's just start with the lesson. Let's just start with the practice questions. For each equation below, model the equation with counters. Use counters to model preservation of equality of addition. Draw a diagram to record your work. Use symbols to record your work. The first one is 9 plus 6 equals 15, right? Okay, the first one is 9 plus 6 equals 15. So you have 9 counters: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 6, 7, 8, 9, right? And then you have 6 counters: 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. You have to add them together and you have to make now 15 counters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so basic thing is you have 9 counters here and 6 counters here, and here you have 15 counters, right? So on the both sides you have equal number of balance, so so this is the reason the equation is balanced. Okay, let's just do an example related to the counters because making counters on the board is very difficult. So let's just look at the example with the, not this one. Okay, just look at this example. Maxim, Max started with the equation each time. 2 plus 4 equals 3 times 2, right? He modeled it using counters. Each side has 6 counters, right? You can see 2 plus 4. Here you have 2 counters, and here he have 4 counters, right? 2 and 4. When you count them together, they make 6. On the other side, 3 times 2, that means you have 3 groups of 2 counters. You add, it makes 6, right? First, Max subtracted 4 from each side. So these 4 he subtracted from this, and these 4 he subtracted from this, right? Each side has now 2 counters. These are the 2 counters he is left with both sides. Second, Max added 2 to each side. Now he added 2 counters to each side, to this side, right? Each side now has 8 counters. You can see after every step, each side has same number of counters, right? Third, Max multiplied each side by 2. Multiplied means he makes two groups of the counter that have same counters, right? So you can see here you have 6 times 2. Here you have 6 counters in two groups, right? So each side has now 12 counters. Fourth, Max divided each side into two equal groups. So both sides he make two groups. You have three counters in each group, two groups of three counters. And on the other side, you also have two groups of three counters. So each group has, in one group, you have three counters, right? Okay, whatever Max did to one side of the equation, he did this to the other side too. Each time the number of counters on the both sides remained equal, right? You can see every step both sides of the counter are exactly equal. So the equation remained balanced. When each side of the equation is changed in the same way, the value remain equal. This is called the preservation of equality. Basic thing is you have to keep both sides equal. Whatever you are doing, just keep both sides exactly equal. So what you have to do, you have to perform same operations on both sides. Like if you are adding, you have to add both sides. If you are subtracting, you have to subtract both sides. This way you can keep the preservation of equality balanced, right? Okay, just look at this example. Suppose we know 6 equals 3t, right? This one represents 6 and here you have 1, 2, 3, 3t. To preserve the equality, we can add same number to each side. Like you added 1 to this side, so you have to add 1 to this side also, right? Subtract the same number. That is these equations, equivalent form of the equations. You added 1 both side, you subtracted 1 both side, you multiplied to both sides, you divided to both sides. They are the equivalent form of the equations, right? Okay, let's just start with question number two. I'm not going to make counters model on the board, right? For each equation below, model the equation with counters. Use counters to model the preservation of equality. For subtraction, draw a diagram to record your work. Use symbol to record your work. The equation is 7 plus 8 equals 15, right? 7 plus 8 equals 15, right? You have 7 counters this side, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 8. Together they make 15. You can even count these counters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 counters on the both side, right? Let's just subtract 8 both sides. It would be 7 plus 8 minus 8 equals 15 minus 8, right? So you have to subtract 8 counters 1, 2, 3, 4, 5, 6. This 8 you're going to subtract, and 1, 2, 3, 4, 5, 6, 7, and these 8 counters you're going to subtract from these sides. Meaning count the counters you're left with 1, 2, 3, 4, 5, 6, 7 on this side. 2, 3, 4, 5, 6, 7 counters on this side because I performed the same step on both sides, right? So if you add, for example, you are adding 1 to both sides, right? Sorry. Again, they are the same counters on the both sides, right? So that means 7 plus 8 is 15 and 1 16, and you can see 16 counters on the other side. Making counters is again and again is a bit long. That's why I'm not going to make the counters on the board. The basic thing is you have to perform the same steps on the equation on both sides, right? Okay, let's just look at question number 3. For each equation below, model the equation with counters. Draw a diagram to record your work. 2 plus 3 equals 5, right? You have to do question number 3 and question number 4 same way we did 1 and 2, right? Let's just do question number 5. For each equation below, apply the preservation of equality. Write an equivalent form of the equation. Use paper strips to check the equality has been preserved. Try to use a different operation for each part. Let's just start with A3B equals 12. So you have to apply same operations on both sides. Let's just add. The equation is balanced, right? Because you added 1 both side. Also, if you are going to subtract, that would be again the balanced equation because you perform the same operation on the both side. So basically these two equations are the equivalent equations for this one, right? You can either divide both sides of the equation by 3. That is also the preservative equation, right? Because you perform the same operation both sides. So b equal 4 is also an equivalent equation for this one, right? Okay. The other one is 2t equals 8. 2t equals 8, right? You can divide both equations by 2. So it would be t equals 4. This one is also the equivalent equation for this one, right? Because you divided both sides of the equation by 2, you perform the same step, right? Now you can add 1 to both sides of the equation. Still the equation is balanced, right? Because you added 1 to both sides of the equation. You are subtracting 1 from the both sides of equation. That would be also an balanced equation. So to keep the equation balanced, what you have to do, you have to perform same operations on both sides of the equation. This way you can keep your equations balanced, right? If you have any question related to the lesson, you can please ask. Otherwise, I'm going to start the new chapter, the new lesson. We are done with lesson 1. Okay, let's just start the new chapter. We're done with chapter 1. Let's just start with chapter 2, that is understanding numbers. So let's just start with the first lesson, that is exploring large numbers, right? Here is the place value chart. Ones, the rightmost digit is always at the ones position. Tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, and 100 millions, right? That is the place value chart. Okay, just look at this place value chart, right? The number, the ones digit is 9, the tens digit is 1, hundred digit is 1, 9 ones is 9. Then you have, okay, if you just look at their place values, 1 9 is at the ones position, so the place value of 9 is 9. But the tens is 1 is the place value of the 1 is the tens digit, and you can write it as 10. So we can write the number in standard form and in expanded form as well, and in the number word form. You can see this one is the standard form. You can write like this. Whenever you have a number written like this, that would be the standard form of the number, right? And the expanded form of the number is you can write the numbers according to their place values, right? You can see here. Here is 9. 9 is at the ones position, so that 9 is at the single one. 1 is at the tens position, so it will be written as 10. Then 10, 1 is at the hundreds position, so it would be written with 100. 9 is at the thousands position, so 9 is written with thousands. When you add all of them, they make exactly the same number, this number, right? And the other form is you can write them in word form, right? 3,159,119. That would be the word form. 3,159,000. That's how you read this number, right? If you have a numbers written like this, how can you read? It would be 3,159,119. This way you can read this number, right? Okay. 1,000 million is 1 billion, right? If you have 1,000 millions, it makes 1 billion. And if you have 1,000 billions, it makes 1 trillion, right? Okay, let's just start with the practice questions, right? Each number in standard form. Okay, write each number in standard form, right? So the zeros tells you the position of the number, right? 4 doesn't have any zero. That would be the very first number in the digit. Then you have 80. 80 means 8 is at the hundreds position. This is ones position. This is 10. 500. 5 is at the hundreds position. 2,000. 2 is at the thousands position. 40,000. 4 is at the 10,000 position. 300,000 position. 3 is at the hundred thousands position. Then you have 4 million. 4 is at the millions place, right? Then you have 20 million. 2 is at the 100 million place, right? So the digit it makes is 243, no, 24,342,584. If you read the number, it would be 24,342,584, right? Okay, let's just look at the second one. 2,276,089. Okay, let me just to 6 million 276,089, right? 6 is at the millions position. Here is the million position. Then after the million you have hundred thousands, then you have 10,000s, then you have thousands, then you have 100, 10 and 1, right? Okay, 276,089. It would be 0, 8 and 9, right? That means you have 100, so it is 0. It would be 6,276,089, right? You have no tens digit here. Tens digit is 0, right? The next one is 2,460,000,000. Let me just copy and paste. Hold on. I have already copied some data. It's okay. Okay, 2,400,000. You have to write it in standard form. What is the problem? Actually, I just copy and paste the number on the board. I just want to copy and paste it. Okay. 2,462,000,000,000. Okay, that is billion. 486. Okay, let me just make place chart. Ones, tens, hundreds, thousands, 10,000s, 100,000s, million, 10 million, 100 million, then I think billion, right? Okay, 2 billion, 400, 460 million, 460 million, 69,000, 69,000, 69,000, 18. It would be like this, right? 2 billion, 2 is at the billions position, 460 million, 460, that is the millions one, right? Then you have 69,000, just 69 you have, so that means 100,000 would be 0. Then 1800 is 0 and you have just 18, so that is the digit it makes, right? Okay, let me be quick. Okay, let's just start with question number 2. How many times as great as 1000 is 1 million? 1 million, yeah, basically you have to see 1 million is how much greater than 1000, right? This is 1 million with 6 zeros, right? And this is 1000. So when you divide 1 million by 1000, you have 1000 left. That means 1 million is 1000 times greater than 1000, right? 1 million is 1000 greater than 1000. Okay, how write each number in expanded form? You have to write them in expanded form. How do you write in expanded form? We'll do just one example because I just want to finish this lesson today. Okay, let me just write them down in expanded form. How do you write? Let's start with the first right digit on the left side, right? 7. How many digits right after 7? 1, 2, 3, 4, 5, 6, 7. Just add 7 zeros. 1, 2, 3, 4, 5, 6, 7. The next one is 5. How many digits after 5? 6. 1, 2, 3, 4, 5, 6. Then you have 3. How many digits after 3? 1, 2, 3, 4, 5. Add 5 zeros. Then you have 0. You don't have to write 0, right? Then you have 8. How many digits do you have after 8? 1, 2, 3. 1, 2, 3. Then you have 4. How many zeros after 4? Just 2. How many digits after 4? Just 2 digits. Then again 0. You don't need to write 0. Then you have just 3. You don't have any digit right after 3, so you can write 3 as it is. If you add these numbers all together, you can even check on calculator. It will make the same digit, right? So that would be the expanded form. Got it? If you have any question, you can please ask. That would be the expanded form. But why I am using a. Okay, the next one is write the write the value of the each underlined digit. How do you write the values of the underlined digit? You can see 2, right? 2. And after 2, how many digits? 1, 2, 3, 4. 1, 2, 3, 4. That means 2 is at the thousands position, right? 20,000s position, right? 2 is at the place value of 2 is 100,000s, right? Then you have 4, right? 4 as it is and add zeros. 1, 2, 1, 2, 3, 4, 5, 6. 4 is at the millions position, right? Okay, the next one is, let's just start with question number 9. Write the number. 10,000 more than 881 10,000 more than 881,426, right? That means you have to add 10,000 in 881,426, right? So when you add, let's just see, 10,000, let me just write it on board. Where is A and B? What's wrong with the questions? Because I just copied C and D. Okay, let's just look at the first one. 10,000 more than 881,426, right? That means you have to add 10,000 to 881. For more means you have to add. Either you can use calculator, either you can use without calculator, right? Be 881,462 plus 10,000. That would be 891,462. Then you have 100,000 less, right? You have to subtract 100,000. To be 2183, 486 minus 100,000. It would be 1183, no, not 100,000. 100,000 just. It would be 2083486. 1 million more than, you have to add 1 million, right? It would be 746 thousands plus 1 million. So it makes 1,746,000, right? 1 million less. So you can just subtract 1 million out of this number. 624,327,207. I'm using calculator. You can also use 1 million less. You have to subtract 1 million from the number. So it would be 623,327,207. That would be the million digit. You subtracted 1 from the million digit, right? Okay. I'm going to skip question number 6. You have to write the number in expanded form, right? You can do on your own. Let's just start with question number 8. Okay, sorry. The largest non prehistoric insect is a species of dragonfly. It lived about this year ago. Write this number in words. Okay, let me just see. What number is it? 1, 10, 100,000, 10,000, 100,000, million, 10 million, 100 million. It would be 280 millions, right? Simply, it would be 280 millions, right? Okay, question number 8 is North America's largest shopping centers in is in Edmonton, Alberta. It covers an area of 492,386 and cost about this one to build, right? These numbers in place value chart. You have to write them in place value chart, right? So 492,386. Let's just make them in number value chart. 1, 10, 100,000, 10,000, 100,000, right? That would be the 100 place value chart for this one, and you can make for the other number also, right? Okay, the next one is a student read this number as 3,146. How would you explain the student's error? Student is not correct, right? That isn't 3,000. That would be ones, tens, hundred, 10,000. Ones, tens, 100,000, 10,000, 100,000 million. That would be 3 million and 146, right? Not 3,000. This one is 3,146, right? Okay, question number 10 is I am a number between 7 million and 8 million. All my digits are odd. All the digits in my thousand periods are same. All the digits in my unit periods are same. All the sum of all my digits is 31. What number am I? Okay, let me just copy and paste the number, then we'll think what number is it. Okay, I am a number between 7 million and 8 million. All my digits are odd. All the digits in my thousand periods are the same. All my digits in the unit period, okay? One, 10, hundred, thousands, 10,000s, 100,000s, million. Okay, all my digits are odd. All the digits in my thousands position are same. That means this one, they are same, right? All the digits in my unit period are same. This one is just unit period. My sum of all the 7 and 8 million, between 7 and 8, right? All digits are odd numbers. Hold on. Okay, odd number. Be 7. Okay, you can see that's the exactly same number. The number is between 7 million and 8 million, right? All the numbers are odd. 3, 5, and 7 are odd numbers. If you add them, 7 plus 5 plus 5 plus 5 plus 3 plus 3 plus 3, they makes 31. Let me just check once it one in once. Okay, 7 plus 5 plus 5 plus 5 plus 3 plus 3 plus 3. Yes, that is exactly 31, right? How do I know? I think that's the only number that sums to 31, because you can see all the digits in my thousands places are same, right? So that odd numbers are 9, 9, 7, 5, 3, and 1, right? But I cannot put 9 over here, right? Because it would be between 7 and 8 million. If I put 9 here, that means the number is greater than 1, right? Then I put 7 here. Okay, then 5, 5. Why I put? Because here is all the digits in my thousands period are same. So that means all the thousands were same. Then you have all my unit are same. That would be 3 here. You can check using this the different numbers. That's just a guess I am trying, and I got the right answer, right? So that is the number. Okay, let's just skip question number 11. You can try the questions I skip on your own, right? Okay, the table shows as to question number 12 it is. The table shows estimates of the populations of some cities in 2015. Order the cities from least to greatest expected population. So you have to arrange these numbers, right? Let's just look at the greater values 22, 22, 27. Least to greatest. Okay, this is the greatest one. You have to arrange them, but least to greatest. Okay, That means last one. Just look at these two numbers. Here you have 7 and here you have 1. 5 is less than 7. So you can arrange that like this: 22 5 7 7 0 0 0. That would be the least one. Then 22 7 6 6 0 0 0. That would be greater than this one. And the greatest one is this one. Right? Okay. Let's just start with question number 13. Explain the meaning of each 6 in the digit. You have two 6 in the digit, right? Here and here. This one is 1, 10, 100,000, 10,000, 100,000, million, 10 million. That is, this 6 is at the tens millions place, right? 10 million, 100 million, billion, 10 billion, and this 6 is at the 100 billion. Both the 6 is at the 10 billion and 10 million and 10 billion, right? They both are at the 10 million and 10 billion places, right? Okay, question number 14 is describe three examples where large numbers are used outside the classroom. The large numbers are used outside the classroom. They can be used in offices where you are doing calculations on large scale. Also, you are going to use large numbers are used in the stores of the, for example, any mart and stores. The next one is how do the patterns in place value system help you to read and write numbers? The patterns in place value makes numbers easy to read and write, right? For example, from this number, how do I know? Because you make the place values. Let me just write them this number according to place value, right? It would be 1, 10, 100,000, 10,000, 100,000, million, 10 million, 100 million, billion, 10 billion, and 100 billion. Reading number is very easy, right? It would be 7 6 3 4 6 5 2 84 132. How do I read the number? 763 billion, 465 million, 284 thousands, and this is the group of the thousands, this is the group of the millions, this is the group of the billions, and that would be the ones. So according to, because of these place value chart, reading number is very easy, right? So patterns help us to read the numbers easily, right? Okay, I think we are done with the lesson. Yes, we are done with this lesson. We're working on chapter 2. The lesson we just covered from the chapter is, if you have any question you can please ask. We're working on grade 6 math. We've started with the chapter 1, patterns and equations. The lesson we have covered from the chapter is keeping equations balanced. Then we have started the chapter 2, that is understanding number. The lesson we just covered is exploring large numbers, right? So if you have any question you can please ask. I'm here to answer all your questions and confusions if you have any. So please just ask question if you have any. I am waiting for the questions from your side. So please ask question if you have any.